Hello everyone! Today we will learn about the application of integral. In chapter 21, it is about kinematics. So, the learning outcome from this chapter will be applying the equation of the relation between velocity, acceleration, and displacement in the derivative and integral process. And then using that process, we can find displacement, velocity, and acceleration at any instant, and also find the actual distance traveled from the direction of motion of its velocity. Before, let's see what is the terminology of kinematics. Kinematics is study of the motion of a body without considering the cause, its motion, focusing on how, instead of why, it moves. In this chapter, we'll using terms such as displacement, velocity, and acceleration. So this is the content of this chapter, and for the first one, we will learn about displacement or distance for the first topic. So what is displacement? From the previous video, you know that displacement is distance with direction. So in here, if it is a straight line, distance of 20 km will be having the direction of east to show its displacement. So it will be different for the distance covered compared to displacement. In here, if you have one turn of path, so the displacement will be a very small way compared to the distance covered after a long journey. Let's see in this example, a particle P moving in a straight line and its distance as meters from a fixed point O, t seconds after passing O is given by s equals 4t minus t squared from 0 up to 4. Then we can calculate for this distance with using the equation. When t equals 1, the s will be 3. When t equals 2, s is 4. And when t equals 3, s is 3. So we can draw the path of the journey of the particle from the fixed point O. Here, when t equals 1, the first position is point A, when position of the particle is 3 meters from the point O. And then when t equals 2, it goes at the point B. When t equals 2, s equals 4. And when t is 3, we can see that the position back to point O. So in here we can see the specification of s. Next, let's calculate the rate of change of s, which is ds dt. So ds dt is the derivative of 4t minus t squared, so we can obtain 4 minus 2t. When you substitute t equals 1, we have ds dt is 2. When t equals 2, ds dt is 0. And when t equals 3, ds dt is minus 2. So we can conclude that when t equals 1, s changes at a rate of 2 meters per second, and it moves away from O at the speed of 2 meters per second. When t equals 2, s changes at a rate of 0, and it stays to be instantaneously at rest. When t equals 3, we obtain that the s dt is negative 2. Can you answer what does this imply? Yes, since it's go back to the first point, the direction is moved back to the position near to O. So that in the second section about velocity or speed, we can conclude that the s dt determines both the speed and also the direction of motion of P at that instant. And later the s dt will be called velocity of the particle at time t. It will be denoted by v. Let's see example 1. A particle Q moves in a straight line so that its distance as meter from a fixed point O on the line is given by s equals 60 squared minus t cubed, where t is the time in seconds after passing O, find first the velocity and the speed of q after 5 seconds. Second, the distance of q from O when t is instantaneously at rest, and the total distance traveled during the first 5 seconds. So for answering the first question, let's see here, we will have the derivation of s, v or velocity, as ds dt is 12t minus 3t squared. So now we can calculate the velocity and the speed of q after 5 seconds. We can substitute t equals 5 and v is 60 minus 75, or it is minus 15. It means after 5 seconds, its velocity is minus 15, while the speed is 15 meters per second. Next, what is the distance of q from O when it's instantaneously at rest? For having rest, then it means the velocity equals 0. Then we can calculate what is the time when it is rest and find out the distance. So first, we have the velocity equation 12t minus 3t squared. We make it equal 0 and we obtain two values of t satisfy this equation. In here, we pick t equals 4 since q has passed O at the time. Then, with this t equals 4, we can substitute to find out the distance of q from O, which is 32. So, it will be how far it is from point O. Next, we will calculate the total distance traveled during the first 5 seconds. We already have the position of s when t equals 4. Now we calculate the distance when t equals 5, which is s equals 25. So, the motion of q will be shown as follows. From the starting point t equals 0, it is at the O position, and when t equals 4, it is the furthest, s equals 32, and when t equals 5, the position in here is s equals 25. So that for this path, the total distance traveled will be counted as follows. It will be 32, the distance from O to the furthest distance, added by this way, which is 32 minus 25. So the total distance traveled will be 39 meters. The last part is acceleration. So acceleration, besides displacement and velocity, acceleration is also a useful quantity for describing motion. Acceleration is the rate of change of velocity with time. Later, we will abbreviate it as A, which is obtained from dv dt, or the second derivative of s, displacement. Let's see example 2. In here, we have a particle travels in a straight line so that t seconds after it started moving, its displacement as meter from a fixed point O on the line is given by s equals 6 minus 9 over t plus 3. The first question, find out the expression for the velocity acceleration of the particle. Next, find out the velocity of the particle when it is 5 meters from O. And the last one, the time t when the acceleration of the particle is minus 1 over 12 meters per second squared. So for the first question, we will find out the velocity from the distance equation. Let's derive v ds dt. So we can have ds dt is 9 times t plus 9 times t plus 3 to the power of negative 2. And now for a, which is dv dt, it will be minus 18 t plus 3 to the power of negative 3. Let's move to the next question. The velocity of the particle when it is 5 meters from O, we will substitute it here. S is 5. Then, when S is 5, we can calculate the time. T plus 3 equals 9, T equals 6. At this time, we'll find out the velocity V, which is 9 times t plus 3 to the power of negative 2, so that we obtain that the velocity is 1/9 meter per second. Last one, the time t when the acceleration of the particle is minus 1/12. Then we can substitute it here. The acceleration is minus 1/12, so we can have t plus 3 cubed equals 216, so that t plus 3 equals 6 or t equals 3. So that's the end of the question. Let's have the summary for the particle moving along the s-axis along a straight line. Its position at time t is given by its displacement s from a fixed point O. By differentiation, we obtain the first one, velocity. V is the change of s or ds dt. And then acceleration is the change of v, which is dv dt. So that's all for this topic. We will continue to the next topic. We will have some more examples to be discussed in our meeting. Thank you all. Stay healthy and God bless you. Bye-bye.